Welcome to the Deep Dive. Today we're tackling something really crucial in tech. How to write code that's not just functional, but effective and, importantly, maintainable.
Yeah, and our guide for this is the book Codecraft. It's really well regarded.
It is. Think of this as, a way to quickly get the essence of what makes great programmers kick.
Exactly. We know you're keen to get up to speed, get those practical insights, those aha moments maybe without getting bogged down in like all the theory.
Absolutely. I
Hmm.
mean, there are tons of ways to learn coding syntax, right? But understanding the principles behind good code, that's different.
That's the core. So that's our mission today. Pull out the key ideas from Codecraft.
We want to help you see what sets the best programmers apart and, how you can lift your own game no matter your current level of expertise.
Okay, so let's dive in. The book interestingly starts not just with technical skills, but with attitude, mindset.
Right. Part 4 asks, A Herd of Programmers, which is a great title. It really emphasizes this point.
It really does. It argues that good programming goes way beyond just knowing the language. It's about your approach.
And it outlines these different programmer types. You might recognize some, like the eager coder or the code monkey.
Yeah, or the guru, maybe the arrogant genius, which isn't always fun, and the planner.
The point isn't really about labeling people, is it? It's more about self-reflection.
Exactly. Recognizing these tendencies in yourself and, crucially, in your team, how do these different styles mesh or, clash? Have you seen that play out?
Oh, definitely. All the time. You see every style imaginable out there. And that ties directly into teamwork, which the book stresses is vital.
Absolutely critical. For most software, the team dynamic can make or break a project. It's not just nice to have, it's essential for survival.
And the book points out common pitfalls, doesn't it? Like communication breakdowns.
Yeah, communication failure is a big one. Or that dictator structure where one person calls all the shots,
Mm.
or satellite teams working in silos.
So what does it suggest for better teamwork?
Well, things like really clear communication channels, obviously, but also practices like pair programming, which can be super effective.
And mentoring too, right? Passing on knowledge.
Yes, mentoring is key. When that teamwork clicks, the whole development process just feels smoother, less overwhelming for everyone involved.
Yeah, that hits on that point exactly. Good teamwork distributes the load. You don't feel like it's all on your shoulders.
Precisely. Okay, so from attitude, let's shift to the code itself, the tangible output.
Parts 3 and V, the shape of code, part of the process. Catchy titles.
They are, and here the book makes a really fundamental point. Programming is a design activity.
Okay, design activity. Let's unpack that. It's not just typing commands.
No, it's about structure, clarity, thinking ahead, and that includes how the code looks, the presentation, the formatting.
It might seem superficial to some, but the book argues it's actually really important for readability.
Hugely important. Consistent formatting makes the code's structure immediately obvious. You can scan it, understand the flow, spot weird things more easily.
And bad formatting can actually hide bugs.
It absolutely can. The book uses the classic example of brace styles and, K&R versus Allman. Seems minor, but it affects how we visually parse blocks of code.
Makes sense. And this leads into self-documenting code, right? Writing code that explains itself.
Exactly. It's not about no comments, but making the code itself as clear as possible. Chapter 3, What's in a Name, is all about this.
Using meaningful names for variables, functions, everything.
Yes. The book really pushes for clarity over being overly brief, most of the time anyway. Make it read like prose, almost.
Except maybe for loop counters, right? I and J are usually okay there.
Right, that's the classic exception. You don't need the current index off loop for a simple for loop. That would just be noise.
Definitely overkill. So if the code explains the what about comments?
Comments should explain the why, the rationale behind a tricky bit of logic, or the purpose of a larger module. They provide context the code itself might not convey.
Got it. Okay, another concept the book brings up is defensive programming. Sounds like preparing for trouble.
That's a perfect way to put it. It's proactive bug prevention rather than reactive debugging after the fact.
So what are some practical defensive techniques it suggests? Like what can you actually do?
Well, a basic one is just turn on all compiler warnings. The compiler often knows best about potentially dodgy code.
Okay, that's easy enough.
Another big one, always check return values from functions, especially system calls or library functions. Did that file actually open? Did the memory allocation succeed?
Right, don't just assume everything worked.
Precisely. And declare variables as late as possible right before you need them. Reduces the chance of using some uninitialized variable by mistake.
Simple things, but probably save a lot of headaches.
Mhm.
What about assertions? People talk about using asserts.
Assertions. The book clarifies their role. They're for-checking internal assumptions during development, conditions that must be true if the logic is correct.
But not for handling regular errors.
Not for general error handling, no, because assertions are often compiled out in release builds, so your check would just disappear.
Oh, right. That would be bad. You don't want safety checks vanishing in production.
Exactly. For actual error handling, the book talks about exceptions. They're a language feature designed to handle failures and separate error paths from the normal code flow.
Okay, so we have attitude, writing clearly.
Mm.
What about the whole process, the development journey?
Yeah, parts V and ASEA cover that. The book stresses having clear software specifications. Functional specs what it does. UI specs how users interact. Test specs how we know it works.
Like having blueprints before you build a house, you need a plan,
Exactly, you need that shared understanding. And then there are code reviews.
which can sometimes feel a bit like being judged, maybe.
They can, but the book frames them as super valuable, not just for catching bugs, though they do that,
It does that.
improving quality, sharing knowledge, building collective ownership, but it requires egoless programming, as the book calls it.
Meaning, don't take code critiques personally. It's about the code, not you.
Precisely, it's about making the product better, which is a good mindset shift.
Definitely. Now, something notoriously tricky. Estimating timelines. Any magic bullets there?
If only. The book calls it educated guesswork, which sounds about right. It acknowledges it's hard.
And points out things that mess up schedules, right?
Yeah, stuff we often forget to factor in.
Yeah.
Vacations, sick days, constant interruptions, supporting old versions, paying down technical debt.
Technical debt, the gift that keeps on taking.
It really does. The book also briefly touches on different ways to approach development itself.
Like different programming styles.
Yeah, structured programming versus object-oriented, for instance, and different process models, waterfall, iterative, agile. These choices shape the outcome.
And the type of software matters too, right?
Yeah.
Embedded versus web app.
Hugely. The context applications, embedded numerical computing heavily influences design. There's no single right way for everything.
So adaptability is key. Okay, we've built it, following good practices.
Yeah.
Now ensuring quality, testing.
Crucial. Codecraft really drills down on this. It defines faults, the actual error and logic, versus bugs, the symptom you see.
And it emphasizes testing early and often.
Absolutely. And critically, it says testing is the programmer's responsibility, not just QA's job down the line. You should test your own code before you even commit it.
Catching things yourself makes sense. It's faster.
Much faster and cheaper. Unit tests are key here.
Testing small, individual pieces in isolation.
Exactly. And automating those tests in a test harness. That way you can run them constantly.
For regression testing, making sure new code doesn't break old stuff.
Precisely. It's like a safety net. You change something, run the tests, and get immediate feedback if you broke anything.
That sounds invaluable. What about debugging when tests fail or users find bugs?
The book outlines a systematic process. First, reliably reproduce the bug. You can't fix what you can't trigger.
Then understand why it's happening.
Right. Deeply understand the root cause. Then create a specific test case for that bug.
So you can prove it's fixed later.
Exactly. And then you fix it. It also warns against over-reliance on debuggers. They're tools, not magic wands. Use them to understand, not as a substitute for thinking.
Good advice. Debuggers can be a crutch sometimes. What about getting the code ready to run? The build process.
The book touches on that. Interpreted, compiled, byte-compiled languages have different processes. The key takeaway is to understand your build system.
And to test the final release build properly.
Yes. Critically important. Test the actual thing you're shipping with the release compiler settings because they can sometimes reveal different issues than development builds.
Okay, nearly there. One last really important topic today. Security.
Yes. Chapter 12, the core message. Security isn't an add-on. It must be part of the architecture from day one.
It gives examples of common problems, right?
It does. The classic buffer overrun is a key example, often linked to functions like scamp or sprintf in CC++ lay, writing past the end of allocated memory.
Which can lead to crashes, or worse.
Or worse, potentially allowing attackers to run their own code. It also mentions integer vulnerabilities like overflow or underflow.
So it's about anticipating these issues.
It's about understanding the risks, knowing the security requirements for your application, and designing defenses in from the start. Balancing security with needed functionality.
Wow. Okay. That was a lot, but some really powerful core ideas.
Definitely. If we recap quickly, attitude matters. Write clear, well-structured code. Make testing part of your workflow.
Understand the whole development process, estimate realistically, and build security in from the ground up.
Exactly. Becoming a code craftsman, as the book puts it, it's a journey, right? Continuous learning, paying attention to these principles.
It really is. So a final thought for you listening. Think about one thing in how you code right now, maybe a recent piece of code you wrote.
Yeah, how could some of these ideas, maybe clear naming or adding a unit test or thinking about an edge case, how could they make that specific piece of code better?
It's worth taking that moment to reflect. How can you apply these principles starting today? Thanks for joining us on this deep dive.